Eastman's Hex-Ray IDA product overview. We're going to go over IDA and what it is and what its functions are. Alright, so just a brief introduction. IDA stands for Interactive Disassembler. What it does is that it's an interactive, programmable, multiprocessor disassembler combined with a local and remote debugger, which means you can both perform it on a computer and externally to other devices. It also supports a plugin environment such as the PE debugger, which I'll go on about later, and other various different programmable add-ons you can download from blogs and whatnot. I'll describe later on. So first things first, I'll go over the three main features, so to speak, about IDA, which is the disassembler, which does binary programs and it maps its execution to help you better understand the processor instructions and in assembly code. Also, generally, the program, what it does, it takes binary code, which is zeros and ones, and tries to make sense of it and convert it to assembly code, which is easier for programmers and general overview people to get a better understanding of the product. So the next thing is the debugger, which I mentioned briefly earlier. It's more of a thing to get past obfuscation in code, which mainly viruses and malware use to hide what they really do. And IDA's main purpose really is to figure out what a program does and it's meant to be doing. And for example, remote debugging allows for harmful programs to be debugged safely in an environment which is controlled by you, so you don't have any unwanted infections or malware spreading to your computers. And also, some debuggers can be run on a virtual environment, but it's really limited to the GDB servers and whatnot, which is I think only one or two right now currently. And then this following picture is just a quick overview of the whole setup of how the debugger fits into the general working environment of IDA, with the assembly structure on the left and the debugger on the right, providing key points to what you're looking at. And also the main other core feature is that it's interactive and programmable, which means that usually programmers know what they want to do, but sometimes they can't get it done without a program. And this is what IDA succeeds in doing. It combines both interactive and smart processing by the computer to allow you to specifically target areas by selecting what you want to do. Instead of letting the program run through as a script, you can jump through text and blocks and areas. And also you can then implement decryption loops, which is more used for malware and viruses. You could simulate encryption to then figure it out by running it in a safe environment. You can also extend supported file formats through files given by IDA Hex-Ray on their website, which we'll show you how to get later. And also automation of IDA to do batch file analysis, which allows you for multiple files to be analyzed by some quick batch. This is an example of how IDA is interactive and actually quite useful for the programmer. It's easy to jump search and jump through all the useless code words. And you can specify things like text, names, functions, addresses to jump right to it. And it highlights it easier for the programmer to actually get a better understanding of what they are. So a brief overview of IDA's licensing types. There are three main types, which is the name, floating, and computer licenses. They made it as easy for the end user to pick what kind of license they want that best suits them. For example, the name licenses is more just towards a single user. So for example, me, Robin, wanted a license. I get a name license, which is tied to my account. So if I want to use it on a different computer, I can, but it has to be on my account. While floating, for example, is more towards big universities or corporations that have about maybe hundreds of computers or so. What you do is you have a license, say 10 floating licenses, and you'd be limited to 10 active computers running at any time, but you can install it as many computers as you want, for example, 100, 200, whatever, different departments, but you'd be limited to 10 active licenses. And then you finally have the computer license, which is more tied down to a computer. So for example, if you want 10 computer licenses, you can install them on 10 different computers, but any user can use it. So it's almost the inverse of the name licensing. And generally, IDA comes in two different versions, IDA Pro and IDA Standard. They're almost identical in the sense that they come with the same features and whatnot, and the other plugins and the decompiler works in both. But IDA Standard is more limited towards only 20 processor types, while IDA Pro unleashes the full 50 processors supported and potentially any further ones that come in. So IDA comes with three main tech features, or really touted new features. The F.L.I.R.T, which is the fast library identification recognition technology, the PIT, which is the parameter identification technology, and the open plugin architecture. Regarding F.L.I.R.T, it's more so used to quickly identify what source code might be compiled with. For example, the virtual library or what have you. It quickly try to identify to make structures and functions recognized quicker through the disassembly. And parameter identification is it tries to stack parameters together so it's easier to make sense of what functions and what parameters are contained within them. I'll go into that detail later. And the open plugin architecture is just the feature I mentioned actually earlier, which is that all the program supports multiple plugins. For example, the debugger in itself is a plugin that's been created to support IDA. And F.L.I.R.T, the creator of Hex-Rays, he actually has a blog which contains almost all kinds of plugins and the competitions that they run yearly. All the plugins are hosted online. And so this is just a little brief overview of how F.L.I.R.T is actually working with the system. For example, it identifies a common function up top, and then it picks out what actual runtime it's being used to do it, which is the virtual library, and then it simplifies it so it's an easy function, sort of more recognizable to the user. Alright, so Graph View is pretty much IDA's way of making browsing the whole program a lot easier for the user. What it does is it represents each function as a node, and each node is linked together to any references or any relationships, which I'll go through in a bit. And it allows you to highlight key areas in these nodes to then maybe jump around or look at better or zoom into further detail into their separate function blocks. The debugger is also completely integrated into this view, so you can actually bring it up while you're in this view to make sure you're looking at the right thing or debugging the right things. And it allows you to zoom in and zoom out to get a better full picture of the whole environment. This, for example, is the graph flow chart, which just shows the program in a flow, how the functions refer and go on as it gets processed on. So you can see down here, it just goes down, keeps going down, and when you zoom out further, it shows the whole program. Function call view, which just shows one function and all the related functions that this one function is called. So it gives you a better idea, for example, if you're executing something, the main function, what functions actually get executed by you executing the main function. It's actually the function cross references. It's almost similar, but what it does is that it shows you which references have been cross references with others, and then it forms an overall view that all related functions are being pulled or called at the same time. It's that you can have the cross-references by themselves, which shows you it's almost a function cross-references, but it shows data views too. And then you have the user-defined cross-references, which is more advanced. Users can specify different parameters they want to have the references restricted into. So IDA, what you might be wondering what you actually use it for. There are three key areas we really do use IDA, especially in governments and Ministry of Defenses. The hostile code analysis, which is malware, viruses, deconstructing them, figuring out exactly what's going on with the net, because nowadays it's called zero-day exploits. And it's used quite a lot by, for example, EIs. In recent 2000s, they had a big breakthrough with IDA, and they shared it with the world, called Fix a Massive Virus Problem. And these data are stored in what they call IDA databases, and they're shared about to other people who are involved in the security industry. Viruses. Vulnerability research is software nowadays is coded fast. Not people are particular with what's being coded. So what it does is it searches through the program, figures out vulnerabilities, and helps you patch up areas that might be weak in the system. And of course, commercial off-the-shelf validation is nowadays a lot of programs are outsourced. So sometimes you're not sure about spying or malware that sneaks into the program, and it might not be the intended reason. So what this does is pretty much above summed up into one other subcategory, which allows you to analyze programs coming outside of your country and better get an idea of what their purpose is. If you'd like to find out any more information or actually purchase the IDA, you can get it from our e-store for quick purchase, right? Or you can contact us at sales@espincorp.com for any further inquiries or questions or clarifications. And that's all. Thank you.